I give you another extra example on how can we use a Green's theorem. Okay, so in this case, okay, we look at the first one on top here. Okay, evaluate the line integral given by the f. This one is already in f dot dr, where c is a circle with the given equation oriented counterclockwise. Okay, so I will call this as example 7. Okay, so now take a look on the example 7. So so what is the circle that we have? X minus 5 square plus y minus 8 square equal to 16 counterclockwise. So we sketch. So the center is shifted at, sorry, the center is now at 5, 8. Okay, so we have to sketch. Okay, so that is the circle center at 5, 8. Okay, 5, 8, and the radius is 4. Okay, now that is the C. We have a counterclockwise and closed curve. So meaning that we can use Green's theorem. Okay, so now we have to find the P and the Q, right? P and the Q. So from the information provided, so this is the P. So we have to find the PY. So e cos x, it is a constant since we want to differentiate with respect to y, so we just only get 3. Okay, and then Q is given by, so this is Q. We have 7x minus sine of y to the power of 4 plus 9y. Okay, so now Q need to be differentiate with respect to x. So everything on the second term here, it is a constant. So we just differentiate 7x, we give you 7. Okay, so now we want to solve the line integral and using Green's theorem. So we have to use the formula qx minus p y dA over the region. So qx 7 minus 3 dA, then we'll give you 4 dA. Okay, so now we have to look at the we have to solve this double integral because our region is a circular region. Then we need to find the solve this using polar coordinate system. Okay, now since our circle is no longer centered at the origin, so we need to find out the R expression. The function of R for this particular circle, where you need to get it from this equation. So the problem now, we have to convert into the polar coordinate system. So what we can do is we expand. Normally we expand the given Cartesian equation. So we have x squared plus 5 squared minus 10x. Okay, and then plus y squared 64 minus 16y equal to 16. Okay, so now we have x squared plus 25 minus 10x plus y squared plus 64 minus 16y equal to 16. So x squared plus y squared minus x 16y, and okay, so the aim is to get the function. Once you expand this into the polar coordinate system, so our aim is to get the r equal to something. So it looks like if you use this way and it turn out to be we cannot get the r easily, unless if this one becomes 0 and we can find out r equal to something. Okay, but in this case it looks like we cannot find the r directly. Okay, so now let's go back to our double integral here. Okay, so from our knowledge when you were in previous subject, okay, you know that we can use double integral to evaluate the area, right? Where the formula to get the area is double integral and the integrand is 1dA. Okay, so now we take 4 out and you have dA. So now you know this one is the area of the circle with radius 4. Okay, so now using the standard formula of the area of circle, so the area of the circle is given by pi r square, pi r square, right? Pi r square. So in this case your r is 4, so you have 4 pi 16 pi. So you got 16 pi. Okay, so now using the formula, the standard formula of the circle, doesn't matter the center. Now this is from our previous formula without using any integration, right? You have pi r squared, or sometimes they could call it as a pi g squared. Okay, so now we replace the r to be r, in this case is 4, so now we've got 16 pi. So now we just plug in the value 4 and then pi 16 pi. So you got 64 pi. Okay. Now you see that sometimes if you convert to polar directly from the equation, you can get easily the equation, but sometimes it's enough to be in this form. Okay. But it is should be no problem if once you simplify your constant here and it turn up to be 0 and you will get the equation of r. But this one is not, you cannot get r directly. Okay, so that is for example 7 for this one. Okay, now next we want to look at this equation, this problem. C is boundary of a region bounded by the xy axis. Okay, and we have a circle of radius 2 and center at the origin in the first quadrant. Okay, now look at example. Example 8. So now let's draw the region. So we have a circle radius 2 center at the origin on the first quadrant. So this is 2, 2, and y-axis plane. Okay, so bounded by the xy axis. How about they don't mention about the direction. But since in this case they mention that, okay, there are two questions here directly, and you can also need to you need also provide the Green theorem. So meaning that if they ask for it, meaning that the condition apply, okay, to use the Green theorem. Okay, so in this case I don't want to show you the direct way, because that one is will be part of your exercise. You can try. So what is the meaning of directly? Meaning that we know this one's supposed to be anti-clockwise direction because you can see here it can be used. We can use the Green's theorem to compute, so meaning that we have anti-clockwise direction and it is closed. Okay. Alright. So if you use the direct method, which means that you have to compute there are three curves, the line segment on the y-axis plane, and also part of the circle equation. Okay, so but I don't want to solve that using a direct way, so I want to show you how can we use the Green's theorem here. Okay, so now we want to get the p first. P is given by x squared plus y squared, and we compute for py, will give you 2y, and q is 3x plus 2y, and qx will give you 3. So now we want to solve the line integral f dot dr using Green's theorem. So qx minus py dA. The region. Okay, so now we substitute qx 3 minus 2y dA, and we have a part of circle, so it looks like we can solve that using maybe we can use, of course we need to use the polar because this is a circular region. So now we convert into polar, so 3 minus 2 r sine theta okay, and then multiplied by r drg theta. Okay, so now this is our region. So we want to find out the limit of theta 0 to 90, so pi over 2, and r 0 to 2. Okay, so 0 to pi over 2, 0 to 2. So now we need to solve this, and I'm sure you should have no problem for this. So 3r minus 2r squared sine theta dr d theta. So I'm not going to solve this for you because this is not so complicated, yeah. And finally, we will obtain that the result is 3 pi minus 16 over 3. So that is for example 8. Then if you use a direct way, of course, you need to provide 3 line integrals, and after that, you have to combine the C1, the C1, line integral along the C1, line integral along the C2, and line integral along the C3, and when you total them up, and finally you get the similar answer. Okay, then you can practice for that for your line integral.